Okay, it looks like it works. Can you hear me, guys? Okay, awesome. So, as you can see already on the slide, today I would like to talk about infrastructure as a code, but using something that is called Pulumi, and mostly because Pulumi can allow you to create infrastructure as code in Python. So maybe a couple of words about me first. Who am I? So I am actually a tech lead co-founder of Flips. This is a still pretty small company located in Poznań. So even though I have this wonderful t-shirt, I'm not officially associated with Pulumi. I got this t-shirt as a thank you gift for being active at Pulumi community Slack. So I highly encourage you to be active there as well, because you can get some free awesome gifts. I'm mostly a Python developer. If I were to describe what kind of programming language I usually use. I'm a big Kubernetes enthusiast, and if I were to tell you one fun fact about me, I'm actually playing Richi Mahjong. So Richi is like a Japanese variant of Mahjong. It's a board game, and for those who think that that's the game available in Windows, this solitaire version, it is not. So if you're interested, try to Google the first word visible in the presentation, Richi, and you should be able to find some proper references for proper Mahjong. Okay, so let's start with what the infrastructure as a code actually is. Because I'm not very good at giving any kind of formal definitions, I basically borrowed the definition from Wikipedia. So according to them, the infrastructure as code is a process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. Okay, that's very formal. What's really important here is that you do not configure the infrastructure yourself by hands, but you rather write some definition files and let some tool to do the work for you. Okay, so now we know what infrastructure as code is. Let's think, why do we need that? It's a fancy word, but we should know why. Okay, so when you Google what are the benefits of infrastructure as code, you can find values such as increased speed and efficiency, cost savings, improved security, version control, and portability. Okay, so why we can get all those benefits thanks to infrastructure as code? Because your infrastructure is defined as code. If you need to change something, you can automate the execution of that code. So that's why you can increase the speed and efficiency. Why can it generate cost savings? Because if something can be automated, it means that you can destroy and recreate the infrastructure as needed. So it doesn't have to run all the time. Improve security, you might ask. Okay, if something is written as a code, you can do some code review. And of course, if that's a code, it's going to live in Git repository, or at least I hope so, so it can be version controlled. And portability, that's something that in theory should work. In practice, okay, let's not talk about this, but at least in theory, you should be able to use the same code against many different cloud providers like AWS or GCP or Azure, and that should help you with migrating from one cloud to the other. Okay, so we covered what, we covered why, so let's talk about how. How does infrastructure as code actually work? In order to answer that question, we have to first fully understand what's the difference between declarative and imperative programming. So imperative is a command like power on virtual machine. So it's basically a command that you're supposed to execute to do. And declarative approach is actually defining the state, the expected state. So virtual machine is powered on. In other words, imperative is like a list of actions, a list of things that you should do, and declarative is, as I said, a desired state. Every declarative command, every declarative description like virtual machine is powered on can be translated automatically into a set of commands. In order to do so, you have to actually check the current VM state. And if the given VM is already running, you can just do nothing, and that's okay. But if the given VM is stopped, what you should do? You should start the VM. So the really important part when we are discussing infrastructure as code is actually something that is referenced as a state. So we've got our source code that is like a definition, a recipe describing the desired state. We've got the current state, and the tool, the infrastructure as a code tool is supposed to use those two values to actually bring the current state to the desired state. So what kind of tools are available in DevOps world when it comes to infrastructure as code? We've got things like Terraform, obviously, the most popular probably, and cloud agnostic. We've got AWS CloudFormation, we've got Google Deployment Manager, we've got Azure ARM templates, and Ansible. But naturally, we also got Pulumi. So what Pulumi is? This is a relatively new project. It was the first GitHub release was around 2017. It's open source, and it has a lot of supported languages. Of course, it includes Python, but it also supports JavaScript, Go, .NET Platform, and as a public preview, also Java and YAML files. If you want to know more, the main domain is pretty simple to remember, just pulumi.com. Okay, so let's end the theory, and maybe let's code something. What do you think about that? Thank you. Okay, so our goal is going to be really simple, because I wanted to make this presentation as easy as possible so everybody can learn something, even if you know nothing about infrastructure as code. So we're going to create a publicly available static website. So let's create a plan for today, right? It's always important to have some plan. So in order to achieve that goal, we have to create a GCS bucket. For those who are not familiar with Google Cloud, GCS is basically the alternative to S3 bucket from AWS. So it's basically a container that can hold some files. We're going to upload index.html to these buckets that we just created. One extra thing, we have to ensure that the given files on this bucket are publicly accessible. Why? Because by default, things on the bucket are not publicly accessible because they might store some like private sensitive data, right? And once we do that, we have to attend a social event that is taking place today. Okay, so let's see how we can do that. I'm gonna try to do all these things like incrementally. So we're gonna see like, so probably hopefully the learning curve is gonna be like very smooth for you. So how to install Pulumi? In case of macOS, you can just use brew to install that. If you're a Linux user, you can use the curl command and pipe that to sh, and it's gonna install the Pulumi for you. I guess Windows users, do we have any Windows users here? Okay, we've got some. So in this case, you have to probably go to the website and use the installation guide there. You just have to download the installer. Okay, so the next thing you should do if you want to make things easy for you for now is to create a Pulumi Cloud account. You just go to this website, pulumi.com, sign up, create the account. You can use your GitHub account if you want, or you can create like a totally separate account using your email address. Okay, so once we have it, once we have the CLI Pulumi available, once we have the account, we can actually create a new project. So if you run this command for the first time, it's probably gonna ask you to sign in to your Pulumi Cloud account. This is not gonna be visible on this presentation because I'm already logged in, but it should be pretty straightforward for you. So how we can create a new Pulumi project? We can use a Pulumi CLI using the command new and giving a template name. So we're going to use the template named Python to create a very minimalistic Python Pulumi application. As you can see, we were asked about the project name, project description, and a stack name. I use all the default values to not overcomplicate the things. Pulumi created a new stack. We're gonna discuss what the stack is later. And it also automatically created a virtual environment for me. Like a standard virtual Python environment, nothing like crazy, something that you should probably know. So if you take a look at the ls commands and see what kind of files were created here for us, you can see the following list. I think you should be able to recognize at least a couple of files here. So we've got this .git ignore. We've got requirements.txt, that's like a standard requirements.txt file for Python, and we've got the venv directory with the virtual environment. Some things that we should discuss are this pulumi.yam file and the main.py. So the pulumi.yam file is actually like a project file. So it contains information about the project name, about the runtime. Why do we have to include that? Because as I said, Pulumi supports many multiple runtimes, including like Java, .NET and others, and of course Python. We've got these options, so you can actually adjust the location of the virtual environment directory and description. Okay, so let's go into something harder. I said that this is like a very minimalistic Pulumi application, but still that's gonna contain some Pulumi code. So please focus really on that, because that's the first Pulumi related source code file. Okay, so that's it. So this is actually like the total minimum that you have to write in order to have a working Pulumi project. So once we have it, let's create a stack. In order to create a stack, you just run pulumi app command. It's gonna use the project that is like the closest to the given directory. So this is what we just created. As you can see, it realized that this particular stack called stack is called dev, demo is the name of the project, did not exist, so it just created it. Yay, how awesome is that? We just created something that does nothing. Yeah, but we have to do that in order to have some start. So now let's talk about something that's finally cloud related. So I'm gonna use Google Cloud Platform as an example. So we have to somehow add support for GCP, for Google Cloud Platform. So how we can do that? We have to install GCP package. Okay, you might wonder how. You're probably gonna be positively surprised that this is just a Python dependency that you have to invoke in a virtual environment created by the Pulumi command in a few slides before. Okay, we have to configure credentials, and this is something more related to our local machine rather than the Pulumi or the project itself. So if you have access to GCP, how many of you use actually GCP at work or privately? Raise your hands. Oh my God, only a few people. So who uses AWS? Okay, so I should have decided to use AWS. But I think you're gonna manage with the examples anyway. So if you run a command like this, you're gonna configure, let's say, your local machine to be authenticated against your Google Cloud Platform account. And in order to configure Google Cloud Project within the Pulumi project, you have to use the pulumi config commands to save some configuration. And in this case, we're using the key that is named GCP project, and I'm setting the value PyConPL-2023. Okay, so when we executed the last commands, this pulumi config command, it actually created a new file that was not present before. And this file is called pulumi.dev.yaml. This dev stands for the stack name that we assigned in the beginning. So this file contains the stack configuration. So project is a project. I think you can vaguely understand what it is, even in case of tool that you didn't know before. So stack is like a particular instance, a particular installation of the given project. So usually you have a project for like setting up your infrastructure, and stack is gonna refer to each environment. So one stack is gonna be defined for the dev environment, the other one for staging, and the other one for production. So this file can be edited manually or using Pulumi CLI. We did use Pulumi CLI using Pulumi config set command, but it can be edited by hand as well. And this is how it looks like. So once we run the commands, you can see that it contains this GCP project key with the value PyConPL-2023. And yes, you can list stacks using Pulumi stack ls. You can see the whole config using Pulumi config. And you can also fetch a single config value using Pulumi config get. Okay, so we got the setup. So now let's create the GCS bucket. How to do that? So the easiest way to see how to do that is either brutally Google it, of course, but considering that you know what you're looking for, you know that you have to have something like a bucket object, but you just need to know the names, references, and other stuff, you can go to the pulumi.com page /registry, and it contains documentation for all the packages available in Pulumi. That includes GCP, AWS, Azure, CloudFront, sorry, not CloudFront, Cloudflare, and other stuff. Okay, so according to the documentation, this is what we should do in order to create the GCS bucket. So what's happening here? In order to declare, once again, in order to declare, because you're using the declarative approach, in order to declare that we want to have a resource, we just have to create an instance of an object. So the fact that we create something like a bucket object from the GCP storage module is actually a declaration that we want to have it. So we're giving it a name, in this case main-website, and we're passing it an extra argument that is actually required according to the docs. And it is because without it, it doesn't work. So you have to give it the location of the bucket. In this case, we decided to use the Europe location. And I'm assigning this object to my buckets variable, but this is optional, so you don't really have to assign it to any variable. The mere fact that you decided to create the object is all you have to do in order to declare that you want to have this resource available in your infrastructure. But I declared that in order to use its output value, that's called name, because I wanted to export something as a bucket name to see the actual name of the bucket. Okay, so let's quickly run and see how it works. But for some reason, I cannot change the slides. Okay, now I can. So we're running Pulumi app just as before. And this time, when Pulumi compared the current state with the desired state, it noticed that we declared a bucket that was not present in the state. So it decided to create a new one for us. Wonderful. And as you can see at the bottom of the screen, there are resources outputs, and there is a resource bucket name with the name that was used for this bucket creation. Great, so now we have a bucket. But we have to add the file with the index.html and take care about the permissions, as I said. So let's update this stack. So what we have to do in order to do the updates, because we are still thinking in a declarative way, we don't have to think what kind of steps should be taken from now on. We don't have to remember that the bucket is already created. We just have to declare the desired state. The job of finding out that the bucket is already created is up to the Pulumi. So we are leaving the code with the bucket pretty much untouched, but we added an extra argument called website to show you that it can alter an existing object, an existing resource, without removing it. We're creating a new resource called bucket object, and as you can imagine, this is an object located in the bucket. We give it a name index. We use the bucket's name as a reference because it has to be located in a given bucket. And we put some context, in this case, some very simple HTML text. And we're creating an extra buckets IAM binding. If you're not into like GCP and you don't know a lot about like cloud permissions, all you have to know that we need to create that resource, reference the bucket, and if we reference a specific user that is called all users, funny name by the way, right? So this user, all users, refers to, as you might guess, all users. So if we assign the role object viewer to all users, the bucket is going to be publicly available for everybody. So let's run this command. So once again, Pulumi app. And Pulumi is supposed to detect what changed. So in this case, it detected that the bucket was updated and there's new field website. And there are two new resources marked with the create plan. you can see that the details of the given plan. This is pretty hard to read at first, but it's going to be useful for you once you need to debug something. We confirm that we want to perform this update, and it's going to create those 2 additional resources, as well as update the already existing bucket. As you can see, we've got some summary. We've got to create 2 newly created resources and 1 update. Okay, so let's test it. It should work, right? So if you need to access something that is located on the GCS bucket, you have to use an address that looks similar like this. So this is a storage.googleapis.com/ here's the bucket's name, and then you can put the path, in our case, index.html. So let's try to use the name that we had on, okay, it's not going to be available because it's on the videos. So yeah, let's copy something that was visible there, construct it, use URL, and it doesn't really look like something that we wanted to have here, right? It's like an ugly XML file telling us that there's no file there. Okay, so let's see what might have gone wrong. So let's list all the files located in the given bucket. And we can see that there's only a single file, but it's not named index.html, but rather index-something. Not good, not good. Okay, so what's the reason for that? Pulumi tries to save you some trouble and uses something that they call auto-naming, meaning that when you want to create a new object, in most cases you don't really care how it's named, right? If you want to create a new VM machine, do you really care what the exact name of this machine is? Not really. If you can recognize it, that's fair enough. But if it has some like random suffix at the end, cool. Why do you have something like this done automatically? In order to prevent from doing conflicts on the cloud. But in this case, we actually want to enforce the name. So you can override the auto-naming feature using input arguments with the name. So if you add something like this, it should actually adjust our object to have a different name. And we're also gonna fix another thing. You might have noticed that in the previous version of this file, I basically used the auto-generated name for the bucket in bucket object and bucket IAM binding. And that's not a good practice because I would have to adjust that code every time I run it because that suffix was random for the bucket as well. So it's quite easy to use an output value from another resource in other resources. So I created a bucket on the top of this file, and I can use the name of the bucket, this one that contains this auto-generated part, in other resources. And what's important here, it actually creates a dependency graph, meaning that it knows that it cannot create bucket object before bucket is created. Because you use the bucket's name while creating bucket object, it's going to ensure that the bucket is created first. Okay, no more talking, let's test it again. Yay, it's exactly what it should be. Okay, but then we would like to improve the outputs. So everything works as expected. Actually, our plan is actually fulfilled right now and we could go to the party, but let's try to do some extra things here if we have some time. So we can create better outputs. In the previous slide, I used this template in order to help you how to create the given address for the bucket. But that would be something that should be like printed out for us, right? So let's export another thing at the bottom of the page. So basically put another name like public URL, use this template and attach my bucket name. Is it clear for you that should work? Yeah, okay. So let's try to actually execute that and see if it works. If you do that, you're gonna get something like this. And I wanted to discuss that even in this like beginner presentation, because this is something that I explain people over and over and over again. I know that it's written in documentation and the getting started, etc. But who reads the documentation from the start to the end? Because I do not. So what it goes here, you have to remember about the fact that all the things that you declared in the Python code are only like a declarations of the resources that you want to have. They are not created when the code is executed. When the code about creating the bucket object is executed, it's not creating the bucket. It's just registering that fact to the Pulumi machine, telling it that we want to have this bucket. And this is all it does, meaning that this is only a declaration, so the name of the bucket might be not available yet. So we have to do something more like asynchronous. Who's writing JavaScript here? Okay, some people. So you might be familiar with like callbacks or joining promises using then function and other stuff. So this is basically what we're trying to do here. So we're accessing the bucket name and we're using the apply function. And the apply function is a Lambda function. So once the Lambda function is being executed, the Pulumi is going to resolve the name. So it's going to ensure that the bucket is created and the name is available for us. So we cannot like access it directly and use string concatenation, but we can use the apply and then do the concatenation in the Lambda function. Another option is to use the helper method output concat. So in this case, it's used to concatenate many different strings, including string outputs. If we do that, we're going to get a nicely looking output with the bucket name, public URL, with the properly concatenated bucket name. Okay, and I guess last thing, because we're pretty much short of time, how to make it reusable. So we should identify all the hard-coded things in our code. So the bucket name was hard-coded to be main website, and it was added like this extra suffix automatically. We hard-coded the bucket location and the HTML body. So we can use this configuration file to store our own configuration as well. And as you can imagine, it's going to basically add all those values to this YAM file, but instead of using the GCP namespace prefix, it's going to use the demo prefix. And the demo comes from the project name, basically. How we can access that from the Python code? Basically, we have to initialize the pulumi.config file, and then we can query, we can fetch all these values. So once we have it, we can basically remove the old hard-coded references and use variables in each place where we need. So we can create the new stack. What I mean by new stack? We've got one working configuration for the dev environment. And now we would like to make pretty much the same, but for production. So normally you would have to remember about all those things and do them manually. Create a new bucket, remember about uploading the file and other stuff. As you can see right here, I basically copied the configuration file. So instead of Pulumi dev YAML, I've got open right now Pulumi prod YAML. And I left the location as it was before. I changed the bucket name to something like nicely looking. I decided to change the HTML body from a generic it works to hello Python. And I decided to leave the GCP project the same because I didn't want to create a separate project for that. I just wanted to have a separate bucket. And as you can imagine, we have to use the Pulumi app commands, but in this case, I'm adding additional flag called -s. S stands for stack, meaning that I'm telling Pulumi that I want to use a different stack than the currently selected one. And it complained that the stack does not exist, and it kindly asked me whether I would like to create it, so I said yes, please. And as you can see, it's planning to create 4 resources at once, but it started with the buckets, and once the bucket was created, it started creating those 2 that were dependent on this bucket. And as you can see, 4 new resources were created. And if we take a look at the stack outputs, we've got new outputs for the given stack. We can also fetch a single value for the public URL. We can use this value directly to use this URL command to test if it works, and it does. It has an altered HTML body, so we should be happy. Great. So last thing, if you're gonna repeat those steps at home, for example, you have to remember that everything that you're gonna create on cloud might sooner or later cost you some money. So it would be nice to clean it up. And cleaning up is pretty easy in Pulumi. So once you have a stack defined, I'm listing all the stacks here using the ls command. And actually, I'm selecting a production stack right now, so I don't have to use this -s flag option. There's a command called Pulumi destroy. And if you use Pulumi destroy, it's basically only gonna do the same as app command, but in the opposite way. So it's gonna ensure that everything that is defined in a file does not exist on the cloud. So it's gonna delete all the resources here. Yeah, sometimes it might take some time, but if you think that's taking a lot of time, try to create Cloud SQL on GCP. That's gonna take you some time. And as you can see, the stack still exists, but the resource count was reset to 0. So if you want to like totally get rid of it, so we don't want to even think about recreating it from scratch, we can remove the whole stack, and that's it. So in summary, Pulumi has projects. In this case, we created a project named Demo, and each project has multiple stacks, probably each stack for each environment. In our case, we created dev, that was created automatically, and then we created prod by copying the config file. Then we have something called resources. We created, for example, GCS bucket. Resources has inputs. For example, bucket has an input called location. And resources also has outputs, for example, bucket name. Because we did not specify the name, Pulumi used auto-naming convention, so we got some random suffix. So thanks to that, we were able to discover that suffix. And we've got some config values that are stored in these additional YAML files. So what would be next if you're interested? Pulumi has some native support for secrets stored on Pulumi Cloud, so you can read about that. You can read more about state and different backends. So currently the state was stored on the Pulumi Cloud, but you can use something that you actually own, like S3, GCS, or even store the state locally. But in this case, you won't be able to easily share the state among different colleagues. You might think about introducing Pulumi to continuous delivery. You can think about testing Pulumi code, and many more. Okay, so that's all for now. And I think we still have some time to answer the questions, or at least try to do so.
Thank you, Jakub. Yeah, so we do have some questions. So does Pulumi have a solid static typing, and how you are using, how you're testing Pulumi code?
Awesome question. So I would joke that if you're using Java to write Pulumi code, you might already know the answer. It's gonna be very strict static typing, but I guess you're talking about Python. So yes, Pulumi code is pretty well type hinted, so you shouldn't have much problems with static typing using things like MyPy or having like auto-completion in PyCharm. Regarding testing the Pulumi code, there are some examples on the Pulumi page. And I don't have much experience with that. That's one reason why I don't want to go into details. And the other one, I don't think we have enough time to talk about this. So just to mention, there is a tutorial for that, and you can actually test the Pulumi code.
Okay, thank you. Does it have a dry run mode with nice cost estimation like Terraform?
Okay, so it does have a dry run, but by dry run, I mean something like preview. So every time I was running Pulumi app, it was giving me the plan first, and I had to accept that. There's also a separate command called Pulumi preview that's going to just generate the preview. I'm not sure how the cost estimation looks in Terraform. Maybe this is something more advanced. So I would need to have some more details. What do you expect from the Pulumi and how the cost estimation looks like? Is there a person who asked this question in this room? Oh, interesting. So I didn't know that Terraform can even have that. So no, I don't think it's like supported out of the box, but this is actually a good proposal to be added to Pulumi. And considering that Pulumi is open source, it should be pretty open to collaboration on that. I wonder how Terraform does that. Is that like a separate plugin for Terraform?
I don't think so. Like,
out of the box?
only Terraform. Yeah.
Oh, here's the detail. Okay. So anyway, I don't think that's supported, but I might ask on the Pulumi Slack. Okay, so next one.
What advantages does Pulumi have over Terraform? When to choose Pulumi over Terraform?
So I assume that person who asked that question is already familiar with Terraform. So I'm gonna use 3 letters to answer you. HCL, and that's the domain language used by Terraform. So basically, I'm a big fan of tools that allow you to use like a proper programming language, in this case, for example, Python, but not only, instead of having like a DSL language. I would say that this is discussable. Some people like to have some more constraints, to have like a DSL language constraints, but as somebody already talked during this conference, I'm not such a person. And from my experience, people are afraid of Terraform, especially people who have no DevOps background and are pure software developers. And when I introduced Pulumi in our company, standard Python developers took interest in writing infrastructure as code, actually. So I see those kind of benefits. And regarding the features, they are mostly on par, except maybe some things like cost estimation that I just got to know today.
Thanks. Do we really need to create account at Pulumi to be able to run it? Okay.
And no, it's not necessary. I use that as an example to keep things simple, and this is like a recommended way, obviously, because you're gonna pay some extra money if you're gonna use that in a company. But spoiler alert, Pulumi Cloud is free for personal use. Why do you need something like Pulumi Cloud? You have to have a place to store the state. For people familiar with Terraform, in Terraform you usually set up like S3 buckets or GCS bucket to store the state. You can do the same in Pulumi as well, but that will require some extra setup configuration. So if you don't want to use Pulumi Cloud, you can't use Pulumi Cloud, or whatever the reason is, there are other options, including like keeping the state locally.
Is Python a good choice for declarative approach?
Yes, I think it is, because even though Python itself is like an imperative language, writing Python, you can actually declare what kind of resources you want to have in your infrastructure. So I would say, what are the benefits? If you want to write something like conditions, like loops, or any other stuff, it's much easier and much more readable to do that in Python or any other high-level programming language than it is in Terraform HCL.
Okay. About Pulumi export, if it's similar to JS promise and asynchronous, perhaps it should be wrapped in await syntax.
Okay, so the thing is that you cannot use anything blocking within the Pulumi project code, because as I said, the source code does not create resources on the cloud. So when I created like a bucket object, the binding for permissions and those exports, that was only like declaring things that I wanted to have. The actual execution is done after interpreting and finishing the interpreting part, and is done by the Pulumi itself. So if you were to put something that is actually blocking, you won't be able to see any kind of result in Pulumi. I hope that kind of answers the question, but I guess this is like the hardest thing to grasp when it comes to Pulumi.
Which shell are you using? Because it looks nice.
I was pretty sure that that question is gonna be here. I don't remember actually. I think this is like Jesus. Maybe I can actually try to look for that. I think there's gonna be some reference in a. It's something that starts with P, I guess. P10K. Try to Google something like P, like power, 10, like the number, and K. You should probably find something. That should give you some guidance.
Okay, thank you. If I need to link several resources together, can I define it in Pulumi? Like 2 Docker services talking to each other?
I would say yes, because I don't think, I don't really understand the problem here. I mean, if you have like 2 Docker services, probably they are like created using, I don't know, Cloud Run, AWS Fargate or something like that. So if they are supposed to communicate with each other, you have to ensure that they are within the same VPC and maybe pass some environment variables so they can actually find each other. So yeah, I would need to have like some more details or more concrete example to give you some proper advice.
Okay, two last questions because we are overrunning a bit. So does Pulumi store infrastructure state, or is it checked on cloud every time? Is it protected from simultaneous applies?
Okay, so if you use Pulumi Cloud, it is protected against simultaneous applies. It checks the state. It doesn't verify the state against the current state on the cloud, but you can enforce that using the Pulumi refresh command, and I guess that's what you were asking for.
Okay, and the last question, can you access outputs of one Pulumi project from another?
Hell yes, and that's a very good question. And this is something you should do if you want to have more modular code. So actually, this is something that is called stack references. So each stack can acquire a reference from a different stack. So all you have to do, you have to like export some value in one stack, and you can depend on it in the other stack. Stack reference, look this term in the documentation, and you should have some examples.
Okay, thank you, Jakub. So if you have any other questions, then maybe Jakub will be able to answer them on social event. So thank you.
You should be pretty much able to find me quite easily. Thanks to that. Thank you.